Okay. Hello and welcome to Fanshawe College Virtual Open House. My name is Jay Park, and I'm working in the International Center of Fanshawe College. I will be the host for today's session. Before we begin today's session, I would like to review a few housekeeping items. First, audience, please turn off your webcams and mics. And second, if you have any questions, please put it in the question box and click on the question mark. Following the session, we will have the live Q&A from the question submits. We will try our best to get through all of your submit questions within this session time. If you have any questions after this session, we recommend you to send us the email at Fanshawe international@fanshawe.ca or book appointments with one of our country recruiters. If you have multiple programs open and running, it may compromise your webinar experience. We recommend you take a moment now to close any open programs before we begin today's session. So I would like to introduce Chris Abo, who will be speaking about electronics and embedded system development at Fanshawe College. Welcome, Chris. How are you doing?
Not bad. Thank you for welcoming me. Good morning, good afternoon, good evening, and good very late at night to everybody that's joining us. I'm Chris Talbot. I'm the program coordinator of electronics and embedded systems development at Fanshawe College.
All right, that's good. So we can start Q&A live session. But before I'm going to ask you some questions, is there anything else you want to share about your programs or area before we move to the live Q&A?
Well, electronics and embedded systems is a newer program. It was designed to give skill sets of a niche sort of industry need. And it's a single 1-year or 2-term program. Generally, it teaches the basic skills of embedded systems development, which includes low-level programming, that's programming for hardware, schematic capture, how to create an electrical schematic, interpret one, PCB design, component research, electronic installation and rework, that's physical soldering skills, and of course, project planning.
Okay, that's really good answer. And we have a few more questions which I'm going to ask you. Well, according to our website, there is an Industry 4.0. Would you please explain about it?
I would gladly explain Industry 4.0. Industry 4.0 is a term that describes a trend or a gap need in our industry right now between our current technology and specific utilization of smarter devices to retrofit to legacy equipment that's in not only existing manufacturing facilities, but equipment that's still viable and can simply be upgraded in order for that Industry 4.0 trend. It's linking information in a real-time way from equipment on the floor or numbers or people's production between manufacturing and service providers into real-time monitoring system for analytic collection. Comes down to data. Managers want to see data. Facilities want to know the efficiency in their specific factories or service industries or offices. And what you're going to find is that embedded systems is the largest industry that's going to expand over the next 20 to 25 years.
Thanks for that great answer.
No problem.
And next question is, tell me about the skill set that is needed for ESD students to excel in this program.
That's a good question. I could probably talk a lot. What I'm going to do is keep it as brief as I can and to the point. It's an earned skill set. It's not for people that don't really want to do anything or float through. It doesn't work like that. It's technically driven. So you have to come in with a good understanding of electrical or electronics already. You have to understand those basic concepts And then what we do is we move into how to program and talk to a computer chip. Without that skill set of communication between a human being and a machine, you can't really do a lot in this field. So that skill set of attention-oriented or detail-oriented, being able to sit down and study and practice, the repetitive resilience of an individual is a skill set we reinforce and hopefully see a lot of students with it, of which I have. Beyond that, the basic understanding of electrical and how it relates to components and documentation is reinforced as well. That skill set is very important. And lastly, we turn you into a professional ready individual who's capable of moving into any job, or for that matter, starting a career, which are not the same thing. Jobs and careers are not the same. A job is something that you do now to pay your bills. A career is something people hire you for. Very, very big difference. So resilience, technically inclined, attention to detail, and of course, a meticulous nature never hurt.
Okay, that's a great answer. Okay, next question. Can you expand on the career possibility for ESD students?
Yes, I can. And I apologize for not being able to give a very specific answer here because it's everywhere right now. If we look at the traditional avenue of travel for a career path in embedded systems, it would start in electronic design, maybe in a small engineering firm, maybe in a manufacturing engineering wing where you're respinning products for future deployments. In the end, every field is now adopting embedded systems. Everybody's looking for smart device interaction, and that's the Industry 4.0 we talked about briefly. Another acronym that's out there is IoT, or Internet of Things. It's the same combination of information analytics being sent to a cloud server, or for that matter, to a phone or to a central hub so it can be analyzed, monitored, and so on and so forth. Really what it comes down to is it comes down to the want by the market that currently exists and the skill set of the people are in it. So shorter answer. Every industry is moving towards embedded systems. Traditionally, it will be in a technical or manufacturing setting, but I've even worked with people in fashion, which blew my mind. We developed an entire body jumpsuit that digitized a human being's movement for animation. There is no limit to what industry you'll work in. Now, I can tell you, you're going to start somewhere that's creating new products or modifying existing products, but God knows where your career will end. You could be working in fashion. You could be working in the food industry. You could be making very intricate little sensors that don't exist anymore. But for that matter, you could be spinning the latest version of the iPhone.
Sounds great. And next question is, what prior knowledge is important for this program?
That's a good question. I'll reemphasize that you must have some background in electrical and electronics. Absolutely. I'm not so worried about if you've done large projects or small projects before, but hopefully you've built something and watched it fail and had to troubleshoot it at one point. If not, trust me, you'll have the opportunity to figure out that skill set too, and we'll reinforce and assist you with that. But in the end, a bachelor's degree or equivalent in electrical electronics is all the prior knowledge you need. As for personal skill set or traits in a human being that would be a successful student, tenacity, meticulousness, attention to detail, and not being afraid to sit down, study, and ask questions.
All right. And according to our website, one of the requirements, this program requires college diploma or degree which is related to electronic or electronic engineering. So most international students who finish university in their country, and also we have students who finish 2-year or 3-year electronic program at Fanshawe. Do you think they can work together because our student only studied 2 years, but overseas students study 4 years already?
That's a good question. Yes. It comes down to what you're doing. Now, having a high level of understanding in that particular field is one thing, but you have to have a basis. Now, there are some allowances for people, say, with a technician diploma to come in. They have a background in electrical or electronic engineering, They understand the basic electronics. And what we're moving into is a different style of utilization. So I want to clarify that point because utilization is a confusing word. We're going to move into, here are practical skills that you may not have developed in your prior education. And all of us are going to be moving at the same pace. Now, what you bring to the table, you bring to the table. That's one of the aspects of why you would be hired by an employer or why you would have value to any team that you would join. I need as many technicians as I need engineers. As a matter of fact, I need more. And there's no problem with an engineer working as a technician, but there might be a bit of a problem with a technician working as an engineer. If this makes sense, my point is that no matter where you go or what you're doing, you're going to be integrated into a team. That team's going to have a diverse background with a lot of people and a lot of different educational backgrounds. I want you to consider embedded systems a lot like a crash course in how to be part of an engineering team, because that's exactly what you're going to be.
Mm-hmm. All right. That was a great answer. Thank you so much.
No
And
problem.
well, most international students, they would like to 3-year post-graduation work permit after they finish some programs at Fanshawe. But electronics and embedded systems development is a 1-year PG program. Would you
Yes.
please recommend any other 1 more year program?
Well, that's a great question. I get it a lot too, by the way. And I do a lot of consulting with students, especially in their second level when they're finishing the program. What do I do next? There's only 2 ways I go with this question. The first way is, what do you want to do? And the second way is, what offsets your skill set and makes you more valuable? Now, I have a weird saying I say to students a lot. I'm going to share it in the open house because it's a wonderful saying and it makes good sense. A lot of students go into a business program or some type of management program. I understand that perfectly fine. But really, why would you be hired? You're coming in with a technical background in education. That's probably why you have your interview. How would a business or a management program offset your skill set? Don't know. I don't know because that's not my forte. I'm a technical person. I build things. That's me. For you, though, it's a deep question and it has a lot of impact: cost, where, location, time. I usually recommend looking at another technical discipline. So because embedded systems is a bridging technology gap, it's between a hardware development, of course, and a software or an IT-based networking styled technology gap. What I usually recommend is that students look at lower level networking programs where you're talking about building infrastructure and networks and getting some more higher level programming under your belt. What that allows you to do is it allows you to step into not only a hardware development engineering team, but also an IoT or Industry 4.0 or geared towards web portaling technical environment. That makes you incredibly valuable and versatile, which means if you don't make it for this job at this company, here's a competitor that's still looking for people. Maybe you fit in perfect there. Your skill set is what's going to draw that employer to call you for an interview. Now, the saying I say the most, and usually makes most students smile, is you can train an engineer to be a manager, but it's really difficult to train a manager to be an engineer. In the end, the choice is on them.
Okay. Sounds good. And next question, what kind of equipment we are using? Because students also compare other Ontario institutions that they would like to know. Fanshawe College might use better equipment compared to other Ontario institutions.
Yeah, relevance in the industry, great question. Let's start with the software side. We teach you to use CAD software in a piece of software that is very universal and intuitive. So if you know how to use this schematic capture PCB design software, you can easily integrate into whatever company's software they're currently using. A lot of companies out there have also a version that is their own proprietary software, so there's no way to get a version of it. We use a more universal platform. As for programming, we move into a couple programming languages, mostly a lower level because we're programming on chips alone. And we program on microcontrollers, straight microcontrollers, not platforms, until level 2, where we introduce a larger built platform that's on a PCB or a printed circuit board. with a number of other integrated peripherals. The majority of your study will be on microcontroller level and interfacing circuitry with those microcontrollers. In that, you'll see development environments, which is software for programming on low-level chips, debugger modules, which allow you to program the chips from a physical connection off of a computer, which is kind of cool. And then lastly, what we do is we set up networking systems, which are chip to chip in a singular circuit. They could be wireless or they could be wired, all depending on the flow of the program for that level. And generally, there's not much variability. Is that an okay answer? Does that describe the things we work on?
Enough answer. Okay.
If I could add one more thing.
Of course,
we physically teach you how to install electronic components and how to remove them.
There we go. Okay. Thank you so much. And I think the student asked, good question. How much of programming skill do I need at the beginning of the course?
Zero.
Okay. So we are ready to teach.
When you arrive, the assumption is you've never programmed before. Your level 1 programming course is called Embedded Systems, of which I am the professor. I will be the professor for as long as they keep me. And I introduce it as if you have no idea what it is and have never seen it before.
Okay, so the additional question, which is related to previous question, student is asking, does the student supposed to know the programming like C or C++?
No.
No? Okay.
No, we actually introduce you to C.
Okay. And also, according to our website, it mentioned we are using CAD program. Does the student supposed to have a really good skill how to use the CAD?
No, we're going to show you your CAD skills that we expect you to know. Then we're going to test you rigorously on it.
Okay.
So CAD is a very open kind of word. It means computer-aided design. We introduce you to schematic capture and PCB design CAD. And a lot of it is software-based. There are some skill sets you can come in with. Honestly, if you understand basic circuitry, DC, AC power requirements for electrical circuits, can read schematic symbols, which we're still going to teach you anyway, you're good to go. It's designed to give you practical skills, because a lot of times coming out of an engineering university degree, there isn't a lot of hands-on. Our program gives you some of those hands-on skills through time, earned practice, and evaluation.
All right. And next question. Many international students also wanted to study which is related to IoT or AI system. I'm wondering, this program also related to those industry?
Yes.
How
now generally,
yeah.
Go ahead. Go ahead.
Sorry, go ahead.
Sorry.
No, it's okay. Go ahead. Please answer.
It depends on what you're building. What do you want to build? We give you that opportunity to build what you want in your practical project, which is at the end of the program in its second level. You'll have an entire term to work with a couple other students that are deemed in your team. Sometimes we let you choose. Sometimes we assign them. I guarantee nothing. You'll work with whoever it is that you're working with and build something that the team agrees to build, where you'll have your influence. There's no problem thinking about what you want to build, when you want to build it. But when you get into level 2, you'll have to define what you're building under our standards, which are geared towards industry requirements. In the end, if you want to make an IoT device, you will have the skill set to be able to do that. The real question is, what do you want to build?
Okay. That was good. To relate to your answer, I'm going to ask you one more question. How do students usually have a group or individual project during their studying in level 1 and 2?
Well, you'll have both. So most courses will be geared for individual work because we are required by our provincial law, that's Ontario inside of Canada, to confirm that students have skills, and it's been verified through evaluations. A lot of your evaluations will be individual. However, we're also required to evaluate how you work with other people in order to accomplish a task in a team environment. You're going to be tried under both circumstances. In the embedded system side, there'll be mostly individual work, cumulative lab projects. We start out with something small, add something to it, add something to it, add something to it. That's a cumulative lab project. And that's designed to be individual to prove each student has a skill set. Then in your practical project and a few other things such as the sustainability in business and electronics, even the project management course, you'll be merged into a team to work together on ideas, practical planning, and of course, physical project building.
Okay, sounds good. So, and also students would like to know how often, bi-weekly, they will have a project or monthly or every week.
Generally, it works on flow with lab classes, which are planned on a weekly basis. So you might have individual assignments or tasks that are due every week, or in my level 2 of embedded systems where we teach higher level programming and more complex algorithms. It's generally done on a 2-week flowing basis. You'll have a lab exercise that you must complete within 2 weeks and demonstrate it. It builds towards an cumulative lab project. And then lastly, for the practical project, because it's in a category all its own, you will actually define when your milestones or when the things that are measurable in the project will be completed. So depending on the course, it's generally a weekly basis for tasks, and they're always bite-sized or small size that are capable to be achieved in a week. In the larger exercises or the more complicated things, you'll be given a 2-week flow, but there's no specific answer that I can provide for that question. I hope my answer, though, gives an idea of how tasks are assigned within the program. Does that make sense?
Yeah, it makes sense. Thanks so much. And student was asking, does a student need a specific laptop, or a student can use any MS laptop or Mac, or it doesn't matter?
Good question. I get it a lot too. I would say that any laptop's fine. The most complicated thing we do is a 3D rendering from your PCB design software. And then lastly, when you're playing with the IoT side or the communication side of microcontrollers, we just run terminal windows like Hyperterminal or PuTTY. I think we're using TerraTerm right now. So text emulation and minor 3D, you should be fine. This is what I tell students when they arrive and ask about laptop requirements. It's your laptop. You're going to use it as your entertainment device, I would imagine. If you can Netflix, FaceTime, and whatever else, you're going to be fine. So specs-wise, anything that's an i5 or greater Intel or equivalent, 4 gigabytes of RAM, decent enough hard drive to save whatever you're going to save on it, will probably generate anywhere between 8 and 16 gigabytes worth of data, program-wise.
Oh, okay, that's good.
Not bad?
Yeah, that's pretty good.
It's your $1,000 for a laptop Canadian, so you figure out what you want. Generally, it's going to work pretty good.
Okay, that's a good answer. All right. What about the softwares and programs during students are studying? Are we going to provide where student wants to purchase?
For materials?
Yeah, like a program.
Yeah, we have an integrated kit bag that will be issued to you as part of your tuition already. So if you've registered for the program and paid tuition, one of the first labs you're in, you'll be given a big duffel bag that says Embedded Systems Development right on the side of it with all the materials you'll need, course-wise, required for the program.
Oh, okay.
It just makes it easier and students don't have to run all over the place to find things. We've also geared back some of the textbook requirements because there's so many excellent open source that we've been able to dump whatever those funds were into the actual materials. You'll have a embedded platform that's about a $71 unit, $71, $80 unit Canadian. It's an excellent unit, but I couldn't provide that if I had 3 or 4 textbooks in there. So what we've done is we've looked at some of the wonderful open source references out there and integrated them into our course because they're fed back into by industry partners. So as the standards shift or change, we have them right there and we're just on track with everybody else. So yes, the materials will be provided to you and it's integrated into your tuition. You do not have to spend another dollar. Your laptop is your laptop. That's not mine. And yes, you should have a laptop if you're coming to embedded systems development.
Okay. So we only have a 4 minute left. So Student also would like to know what kind of job they can expect after they finish ESD2 program.
Sure. What are we talking? Are we talking money or are we talking position?
Well, actually, both.
Both.
If you
Okay.
don't mind. Yeah.
Generally, if you have a bachelor's degree in electrical or electronics and you get a one or two postgraduate certificates, you're probably going to step out of the education and into the workforce in a related field, somewhere between 50 and 60,000 a year. And that's generally what we see. Now, those numbers change from year to year, but Fanshawe College actually posts a document that says expectation for graduates. Starting as a junior engineer somewhere, it's probably somewhere between $50,000 and $60,000 Canadian a year. I haven't seen a lot of variance on that. I would have to say and set the expectation, don't think you're going to step out of school and be a manager. That's not how it works. I don't see that working anywhere. And I've interfaced with people from Peru to Russia to Korea to China to India. I've never seen a student step out of school, go directly into a manager's position and stay there. So
It's
you're going to
really
have 2 or 3 years where you're a junior something or other and you're doing a lot of work. Then maybe, just maybe, if you've demonstrated your skill set enough, somebody's going to give you a team to run. Now you're in business.
Sounds good. Thank you so much. And also one student would like to study master after finish ESD2. Would it be possible? PG program will help students to
Yes,
start the master. Do we have
yes.
any partnership?
We don't have partnership. However, Western University in London, Ontario has accepted a number of graduates from the ESD program into a master's program. And after about a year, sometimes it's 10 months, sometimes it's 13, 14 months, all depending on the flow of their master's committee, the students have been successful in getting their master's. I have a student right now. Her name is Precious. She's a wonderful lady. She's finished her master's already, is no longer required to take any education for a work permit, and is actually into a work study slash PhD studies. So she's going to be better educated than I am. And she's a wonderful person. And that's the one like super successful student I've had. I've had about 6 to 10 ESD students that have gone for their master's at Western with no issue whatsoever. You're not limited to go to Western. You could go to the University of Waterloo. You could go to McMaster University in the general Toronto area. Plenty of places to go. And yes, master's programs are possible coming out of any of the specific technical disciplines you'll find at Fanshawe College.
Okay, so I'm wondering if a student will study master in Western University. I'm wondering our student will have advantage to enter Western master program. Are they going
Excellent
to accept some
question.
credit or no? Yeah.
Well, master's programs aren't necessarily just study at this point. It's one thing to get a bachelor's degree, but getting a master's and a PhD are very different levels. And a master's level, they're looking for you to do something and prove something. So you start with your master's thesis, then you have to turn out and start developing experiments. Here's the question, the real advantage, right to your question. Somebody with practical skill set versus somebody freshly coming out of university, moving into master's that does not have that practical skill set. Who do you think is going to be more successful in design of experiment, data analytics, and communications? Probably the person with a little bit more experience using their hands, maybe watching something explode and troubleshooting why, or for that matter, somebody who has had a lot of interfacing with very experienced people, gifting some wisdom as they go. That would be my idea of the advantage, and I have a few successful students that prove that works.
All right, that's amazing answer. Thank you so much. I think we are going to end the season because now it's reached the end of our season. So, 1 second, I'm going to share my screen. So I really like to say all of the students who submitted the questions today. We hope that we answered all of your questions, which we did. But if you couldn't have time to ask us, feel free to contact international@fanshawe.ca, or please go to fanshawecollege.as.ca. Then you can make an appointment with one of our contributor creators, that we can have a one-on-one meeting. And also, I really like to say, Chris, you spend a lot of time for international students to provide a lot of unique information today. I really appreciate it.
Thank you. Thank you very much, everybody, for attending. It was an absolute pleasure, and I hope to see you at Fanshawe soon.
All right. Thank you so much, and have a great day. Hope to see you
Bye,
next time.
guys.
Bye-bye.
Thank you, sir.